Okay, so here we go again. We're going to pick up where we left off yesterday. We were solving linear systems by graphing. This is Miss O'Brien talking. We are still in lesson 7.1. We are going to finish it up today by practicing graphing linear systems using paper and pencil, graph paper. But also we're going to explore a little bit with the TI-84 graphing technology as well. So when we left yesterday, the last problem we did was this linear system, and we came up with the solution 2, -1. So I would like to show you how to check that answer on your graphing calculator. So if you have your TI-84 calculator handy right now, you could open it up and turn it on, and then you're going to go to this y equals button here where you could type in two different equations, and our equations are y equals -2x plus 3, and the other equation was y equals 4x minus 9. Remember where to find the y equals key up here at the top and where to find the x key there. Okay, so when you graph this linear system and you make sure that you differentiate between using the negative sign on that -2x, there's the negative sign, and then the minus sign on the 9 here would be used with this key right here. So once you get those two equations in, you can hit graph, and there's the first line and the second line, and that indeed does look like the picture that we have right here. So I can kind of make this a little bit smaller so we can see both. Okay, so you can see that the graph that we made by hand matches up with the graph on the calculator, which is a good thing. That means we've probably graphed it right. Okay, so we can hit the trace feature here at the top, and if we trace to the right, it gives us an approximate intersection point right there, and we can see that our approximate intersection is where x equals 2 and y equals -1, but those are not exact values, and so we could actually tell the calculator to find those exact values for us. Right above the word trace in blue letters says the word calc, which stands for calculate. So to get that blue function, we're going to access that by hitting the second function button first, and then trace to get that calculate feature. Once we're in that calculator menu, we're going to type number 5 for intersection point. And then the calculator will ask us 3 questions. The first question is, are you on the first curve or the first line? And if you look up here, it says y1, and yes, indeed we are, so we hit enter. And the second question it asks you is, are you on the second curve or the second line? And you look up here, it says y2, and you are, so you hit enter. And the third question says take a guess, and so you want to get pretty close to that intersection point so that you can tell the calculator, I think it's right about here. Hit enter, and you do get the intersection point to -1. So you can see this answer matches up with what we already have for our intersection point to -1. Okay, all right, let's try that again. We will try that on the next problem, but we will first graph it by hand. So our next problem is y equals -3 over 2x plus 4. So now we are going to start with, on the green line, we're going to start with a y-intercept of 0, 4. So I'm going to grab my green pen and go to the y-axis and plot a point at 0, 4. That's the y-intercept. And then I'm going to use a slope of -3 over 2. That's rise over run. So from the y-intercept, we are going to move down 3 over 2 to the right. And then plot another point. And then from there, again, move down 3 over 2 to the right. And plot another point there. And I'm going to do that one more time. Down 3 over 2 to the right, and plot another point there. Now the reason I want to plot so many points is because I want to get a nice straight accurate line, as I said yesterday. If you only plot 2 points, it's really difficult to extend that line accurately. So I'd like you to try to plot 3 or 4 points and then make sure that you use a nice straight edge, a ruler, to draw that line accurately with a nice fine pencil point. You always want to use pencil when you're doing math because we're bound to make some mistakes and we might need to erase. Okay, Second line is going to be plotted in purple. I'm going to do it in black first, and then I'll change it over to purple. The y-intercept here, this equation really says plus 0. It's the way I'd like to look at it. So the y-intercept here is 0, 0. This is a direct variation equation. It goes right through the origin. Okay, from the y-intercept, our slope is 1/2, so we are going to rise 1, go over 2 to the right. So up 1 over 2 to the right. Hopefully you can see that intersection point right there. Up 1 over 2 to the right again. Up 1 over 2 to the right again. Going to draw that nice straight line. And after I draw it in, I am going to shade it purple so that it matches my equation. So later on when you look at this, it'll make a little more sense to you because the lines are color coordinated. Okay, now we're going to identify that intersection point. Okay, remember you always want to circle that point of intersection to indicate to me that you know where to find it. So I'm going to circle it in like yellow, highlight it there. And then we're going to name that point using the coordinates, and the coordinates are 2, 1. So the solution is 2, 1. Okay, now we are going to go to our calculator and check that answer. So remember how to type in an equation, and we're going to go to y equals and clear out both of those equations. And then in the first equation, we are going to type in y equals -3 over 2x plus 4. So here's the -3 divided by 2, and then there's the x key plus 4. And then enter. And the second equation, 1/2 x, 1 divided by 2x. We do not need to type plus 0, although you could if you would like to. And then if you hit graph, you will see the picture. Should look just like we've already graphed by hand. Let's compare it to our graph. Looks pretty good. Now we're going to use that calculate feature. And to get the solution, we hit this button here that says second trace, which is going to access the blue calculate feature there. And then number 5 for intersect. And then first curve enter, second curve enter. Take a guess. I'm going to scroll over to the right and get a little closer, hit enter, and I get the intersection point 2, 1, and I would like you to see that that matches up with the answer we have already. Okay. All right, this third one. Kind of would like to ask if you notice something special about these two equations before we actually graph them. So pause and write down something that you see as special here. So hopefully you saw that both of these equations have a 3 in them. And if they do, then their graphs would start at the very same place. So the green one will have a y-intercept of 0, 3 and a slope of 2. So from there we are moving up 2 over 1 to the right, up 2 over 1 to the right, up 2 over 1 to the right. And then I'm going to go ahead and connect those points, make a nice straight line, color my line green. And then when we plot the second line, it also has a y-intercept of 0, 3. So I'm going to start at the very same place, 0, 3. Looks like that might be my intersection point. But from there, I am going to move down 4 over 1 to the right. Because my slope is a negative, down 4, 1, 2, 3, 4, over 1 to the right. And I could do that one more time, but it looks like I have a pretty good pattern going here. Could easily draw that line in. I'm going to color it purple. Because I like to color coordinate these lines. I'm going to highlight that intersection point, which is my solution. So when you read the solution here, the solution is 0, 3. Now we're going to check it on our calculator. We're going to type y equals, clear out those two equations. And the first equation was 2x plus 3. And the second equation was negative 4x plus 3. Just be careful with your negative there. And then hit graph. Hopefully your picture looks a lot like the one that we made by hand. And then to get our intersection point and check it on the calculator, we're going to type second, calculate under the trace feature, number 5, enter for the first curve, enter for the second curve, enter for the guess, and it tells us our intersection point is 0, 3. So now you know how to check your answers on the graphing calculator after you graph linear systems and solve them on graph paper. You are now ready to try the practice.